All right, so here we go in 2-2 with limits involving infinity, featuring a graph from the movie Mean Girls from the math contest at the end. If I want to graph y equals f of x, this is what that graph looks like. I could give you 4 different scenarios to talk through that all involve limits that involve infinity in one way or another. I can talk to you about x being incredibly large, but being positive. And you could either think this through or you could follow the graph. If x were an incredibly large positive number, and you play the plug-in game, what would happen if you plugged in an incredibly large positive number?
Get an incredibly small number then.
You would get an incredibly small number back, which would be positive or negative?
Positive.
It would be positive. If we wanted to try to follow the graph, where would you go on the graph to find an incredibly large positive number? Where do positive x's live if they're very, very, very large?
I'll think here. So like quadrant. Wait, never mind.
Very, very, very large positive x's. The choices would be up, down, left, or right.
Right.
To the right. If we want to go positive, we're headed right. If we want to go large, just head to the right really, really far down the line. If you were going to follow this forever, how high does that look like it's eventually going to be? Where's this going? To what height? Roughly.
Like 0.00001.
Yeah. That's almost like measuring my distance to the cabinet from the story from previous lesson. You know, we're getting really, 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 really close to 0 at some point. The way we could write this is, if x is headed forever that way, what's the best name for that location if we head forever? What number is that? We go right forever. Where are you? Infinity. So if x approaches infinity, the 1 over x part of this is getting really, 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 really close to
Negative.
0. But it's always a little more or a little less than 0, no matter how big the x would get. Always a little more than 0. And that sign just means it's a little more. We just did this question. No, I didn't. I could write this as the limit as x approaches infinity of 1 over x would be 0. I'll make this analogy for the first time. My easiest way to explain this with the real world situation would be something like, if we're trying to have x be infinity, if we have 1 divided by infinity, my best way to imagine this is, imagine you were on a missions trip and you were going to try to feed China. Everybody is hungry. You're going to feed everybody in China or Asia or some giant place, the globe if you like. And you take with you on your trip 1 cookie. You're going to take 1 cookie and you're going to divide that among some ginormous group of people. Everyone that lives in China gets a piece of your cookie. How much cookie are you giving each person in China? Essentially, 0 cookie. Like there's not, if you take 1 and you divide by an incredibly large positive number, there's almost nothing left. Everybody would get like 1 molecule of cookie, right? So 1 dividing infinity, more or less is 0. That's our first limit involving infinity. What if x is small but positive? Where would that be headed? either by thinking it through, by like, imagine you're plugging in a number like that, or by following the graph to the right location. Anybody have a thought on if X is super small and positive, what that would do to Y?
Really big and positive.
It would be super large and positive. So if you're imagining a plug-in, we'd be imagining something like 0.00001, some kind of tiny fraction. If 1 divides by the tiny fraction, what happens when you divide fractions? You flip it. And when you flip a tiny thing, it becomes ginormous. Or if you were thinking about a decimal, imagine putting one of those kind of decimals out there. What's the first thing you have to do to divide decimals?
Make it over one.
Yeah, we have to move that over. And if you move this over, you have to
Move that.
move that over. And now that just became gigantic. Or if you want to follow the graph, where could you find a really small but positive number? Where would you be headed if we're trying to find really little but positive x's? We'd go if we're trying to follow this kind of thing, where on this would we head if x was tiny and positive?
And straight on.
Yeah, like through the roof. A tiny x would just be over a touch, and then the graph is headed like forever. So in this, who was x approaching? Small and positive. How could we like capture that with math symbols?
0.
Little plus, little minus. Little plus, we're a little more. And then the y went through the roof. A name for that is infinity. And I just did that one. X was approaching 0 from the right, 1 over x, it got infinitely big. Right now we're just thinking so you can understand the kind of like what this is supposed to be doing. I'll get you a set of rules that'll speed this process up along. So if you're thinking, boy, am I going to think like this every problem? The answer is no. The thought process is true, but it's not going to be necessary long term. If I give you a really large, really negative x, what would that do to the y? I'll drop you the hint that we've already handled this area and this area, and we won't go double dipping. We really get a small negative value. X is approaching, what would be a name of a gigantically large negative number? Negative infinity. What would be the name of a tiny but ever so slightly negative number? 0 with a little minus. So we could say limit as x approaches negative infinity, that's also 0. If you take your one cookie and divide it by China again, even if there's a negative involved, still no one gets any cookie. It's still 0. On the graph, where's that headed? Super large negative x's. Where are those? To the left. That's headed up to 0, but from the negative side of 10. So we're only left with the other combination. So small negative x's would get you large negative y's. So x is approaching from the left. The 1 over x is getting close to negative infinity. Where that just went is through the floor. If we were tiny and negative, that's just left a little bit. And then it would be all the way down through the floor to negativity. And that is this one. This is called a left-handed limit. That was previous lesson vocabulary. This is called a right-handed limit. That's new lesson or previous lesson vocabulary. What was this called?
Two-sided.
Two-sided. When were we able to do the two-sided? If left and right agree. So in this case, it's impossible. The limit does not exist, to quote Lindsay Lohan from the country moment of the context. I made this gesture to you on Friday. Like when the two pieces don't agree, the limit does not exist. And that's what's going on this one. This is soaring off to the heavens at 0. This is plunging to the depths at 0. It's not just disconnected a little bit. It's like, whoop, that's as far apart as two things could be. That two-sided limit would be a failure. So here's a rule. If I'm doing limits as x approaches infinity stuff, and I work a number in the problem, the number will just sit there. And I'll show you this rule in effect in about 30 seconds. But if the limit is x is approaching infinity, there's just numbers hanging out. The k means it's a constant, it's a number. That number will remain unchanged. The limit as x approaches infinity, 1 over x. We just did that one, that was 0. That's my cookie to China. So if I want to do limit as x approaches infinity, 1 divided by infinity, you've got no cookie. So if I put those previous two things together, what do you think the limit as x approaches infinity of 1 over x plus 5 would be? But because the 1 over x part was 0, the 5 part is just a number, and that first rule I just alluded to 30 seconds ago was saying, just leave 5 alone. It's like 0 plus 5 makes 5. Question about the concept of what you're doing. Here's how the homework's going to break down. Half the problems are going to have infinities in the problems. Half the problems are going to have infinities in the answers. But every problem is going to involve infinity in some way. Okay, what I'll always give you, what the book always gives you is x's. So sometimes they're going to give you x's that are infinities. Sometimes they'll give you x's that are numbers, then your y's probably come out to be infinities. That's just how this lesson's going to be. So here's option 1. If they give you limits as x approach numbers, that's like problems you did on the previous homework. What did you try to do when they gave you limits where x was approaching a number? You just kind of try to...
Plug in a number really, really closely.
Yeah, you just plug it in. You just take the number and you plug it in. So if we're doing limits as x approaches numbers, you're just going to try to plug them in. If you're looking at a fraction, sometimes you can get infinity type answers, positive or negative, if you end up getting a number on top of 0, and if you can decide on the sign. And I think that was a question that came up Friday. Friday, you had a lot of 0 over 0 questions. We factored, canceled, did stuff to like remedy the situation. Today's lesson is going to be more, there's some other number over 0. You can't factor, you can't cancel, it's not fixable. What you're going to do is probably go with an infinity answer, but you have to be able to decide on the sign. So for example, these three we already did. If I say we're approaching 0, plug it in. If you plug in 0, you get some number on top of 0. This is definitely less than 0. So a positive dividing a negative would make a negative. That is negative infinity. Move on with your life. Likewise for this. If we try to plug 0 in, number dividing 0 is probably infinity. This is a little bit positive because it's more than 0. A positive dividing a positive makes a positive. That's positive infinity. This has no answer because if you try to plug it in, it's a number dividing 0. But I didn't tell you if it's more or less. You don't know if it's positive or negative, so you just can't do that answer anymore. I'll say for the first time, beware the two-sided limit. You probably in your neighborhood have signs, beware of dog. Beware the two-sided limit. Very often the two-sided limits won't have answers. Let's do another go round. So if I tell you I want to do the limit as x is approaching 1. This is 3 different versions of x is approaching 1. All 3 of these would involve you plugging in the 1. All 3 of these would involve having a number on top of 0, number on top of 0, number on top of 0. The question just then becomes, can you decide on the sign? So if we're a little more than 1, plug that in. The bottom would be a little bit positive or a little bit negative. if we're a little more than
A
one,
little more.
a little bit positive. The top is positive, the negative's positive, the total value would have to be, the bottom's positive and the top is positive, the total would be
Positive.
positive. So that's positive infinity. This means we're a little less than 1. So if you plug in a number a little less than 1, you do the subtraction, the bottom would be a little bit
Less than 0.
less than 0, negative. So if the bottom's negative, the top is positive, that's negative infinity. Here we have a two-sided thing, and always beware of the two-sided limit. Since the right went one way and the left went another way, this is impossible. I'm going to do some what-ifs before I cross the line, but question before I cross the line. Basic rule is, try to plug the number in. If it's something on top of 0, think infinity, but you have to be able to commit to a sign. The one-sided limits, you generally can't. The two-sided limits, frequently you can't, so beware of the two-sided. You can sometimes do a two-sided limit and have it exist. Let's say I go like this. I just took away the uncertainty with these. If I throw these on there, we are now sure that that is positive or negative?
Positive.
Positive. Because the bars made the bottom positive for sure. The top was positive, so that's positive. What if I also went like that? The bottom is now for sure positive, the top is for sure, so now that's a negative infinity for sure. Even though it's two-sided, I can still do it because the bars gave me some help. How about this? Are we sure of sign? Yes, we're sure that that's positive. Now we're sure that it's negative. Okay, so there can be two-sideds where you're sure, but there have to be a special circumstance usually to be sure about it. Did you have a question?
Yeah. What do you mean by you can decide on the sign?
You know whether the total value of the problem is positive or negative. So like, for this one, if we're a little more than 1, if x is a little more than 1, the bottom, when you subtract 1, is a little bit positive. The top was guaranteed positive. Positive dividing positive is positive, so that's positive infinity. If I went like this, the bottom is still a little bit positive, but the top is negative. A negative dividing a positive is definitely negative. I can decide on what the sign would be because of the one-sided. If I went like this is still a little more than 1. If 1 subtracts something a little more than 1, the bottom would be a little bit negative. The top is negative. A negative dividing a negative is positive. As long as you can do the mental gymnastics to come up with the sign, it's that type of infinity. But if I just say this, we can't do that one because I'm not committing to, is this a little more than 2, which would be a positive bottom, or is this a little less than 2, then it would be a little bit of a negative bottom. The two-sided limits, there's usually uncertainty there, and you usually can't do them because of that uncertainty. Or if we want to go back to graph, like this is going to happen. You know, the way that first graph, it had the low road and high road. They just don't go to the same spot if we're thinking about Mr. Spider from Friday. Any other questions before I cross the line? That's one way that infinity appears in some of the answers. Okay. The last group, we're going to go limits where x is approaching infinity, and they're going to give you a fraction. So there's a 3-part rule for this. We're going to look and see what is the degree of the top and what's the degree of the bottom, to dust off an algebra word. Let's explain that word before we forge ahead. Either of you have an opinion on what's the degree of the top? Remember that word at all?
5.
It's not 5. Second guess, the degree of the top is 3. What's the degree of the bottom? 2. What's the degree of this top? 2. What is the degree?
I was just going by the highest, like.
Highest exponent. Highest exponent on a variable is the degree. So if the top has the higher degree, you're going to go with an infinity answer, but you again will have to decide on the sign. If the bottom has the bigger degree, that's going to be 0. That's going to be your favorite one. And then I made a mistake, lost my concentration here. If they tie, we're going to make a fraction out of it. Let's look for this because it's the easiest rule. Okay, if the bottom has the bigger degree, we're just going to get a 0 answer. Which of these 5 has the bottom with a higher degree, and that's going to be a very quick hitting answer? 2. Answer is 0. Because the bottom had the higher degree, it's over. Question about that rule? Second easiest is if you get a tie top and bottom, to just write yourself a fraction. Which of these has a tie for the degree? And we're going to write ourselves a fraction. 3. What fraction do you think? I'll tell you. 3/2. Because this doesn't really matter. Okay, think about what's going on here. Our x is infinite. So we're going to take that infinite number and we're going to square it. And we're going to multiply it by 3. Oh, and by the way, we'll add 4. How much does adding 4 really do to that pile of numbers? That's basically worthless. On the bottom, you're also squaring that infinite number. You're doubling it. Oh, and throw in another 5. Like, those numbers are just basically pointless. Okay? If you had the same infinite number and you squared them both, these are essentially canceling each other out. And the 3 and the 2 is really deciding like what the difference is on the tops. Multiplying a giant number by 3 and 2, that has an impact. Like adding 4 and adding 5, that makes sense. Question about that? As always with fractions, be on the lookout. Maybe sometimes fractions can. Back to elementary school.
Reduce.
Yeah, they might reduce. If you could reduce the fraction. Question about those two are quick hits again. If x is approaching an infinity, whether it's negative or whether it's positive, the same rule applies. It doesn't matter. Okay, so any kind of infinity, bottom's bigger, 0. Any kind of infinity, they tie, fraction. If the top is bigger, that's going to take a little bit of thought for us. Okay, so top is bigger, it's going to be some kind of an infinity kind of thing. We're going to focus on this. Ignore this, focus on this, and ignore that, and just decide on the signs. I'm putting in a positive number. A positive gets cubed, a positive gets squared. We divide those results. It's got to turn out positive, so it's positive. Question about that? Okay. There's a what if. If I go negative going in, if a negative gets cubed, that's negative. If a negative gets squared, that's positive. When a negative divides a positive, that's a negative. That makes sense? If I throw on here a -3, well, the negative when it's cubed was negative, but multiplying by another negative just made it positive. The bottom, because it's squared, is going to be positive, all positives. It's positive. Unless I throw on a -7, right? So now the odd power is negative, this coefficient's negative, this coefficient's negative. The even power's positive. 3 negatives would make it,
I lost track.
so we had negative because of the odd power,
Okay.
negative coefficient, but a positive from the square.
Negative.
So that's a negative.
Okay.
Unless I made this 1. So now this is negative. This is negative. This is negative. This is negative. 4 negatives.
Plus.
Negative. Okay, so you're just going to have to do some mental gymnastics about signs, but only on the one that caused the degree. So here, we don't care about the 4. We just need to focus on this and this. Put in a positive, what would the grand total be? Negative or positive?
Negative.
It is negative. I'm too close to the air purifier, so I'm in trouble hearing when I get too far away. There was 1 negative coefficient, and then if we're putting in a positive, everything else would be positive, so 1 negative would make that negative. I could do some more what ifs if you didn't get the point of the last series of what ifs, or you okay?
I think we're good.
You're good?
Yeah.
So on this, don't care about that, don't care about that, care about the 2 champs of the signs. I'm putting a negative in. So there's a negative to the third, there's a negative still regular, there's a couple negative coefficients, the grand total, all that would be
Positive.
positive infinity. There shouldn't be any no answers in this club. Okay? If x is approaching a number, there's going to be some no answers in that club. But if x is approaching an infinity, you're either going to get fractions, zeros, or some kind of infinity. Maybe it's positive, maybe it's negative. You have to decide on the sign based on the degree, the top degree on the bottom, making comparisons of what's going on. That's our thing.